Okay, 3, 2, 1, action. It's April 5th, 6th period, 2011. I'm practicing my think aloud so that you can experience the way I think about laboratory investigations. Ready, set, go. Okay, as I read this first paragraph, I realize it's an introduction to the laboratory. I never really thought about it. I'm pretty sure that balls always stop rolling. That's always the case it has been. One thing that surprises me is that Mr. Schmidt seems to be asking me, why do balls stop rolling? And I never thought about why they stop rolling. And the only thing I can think of is that the energy transformation must have something to do with that. And I have evidence of that because it says changes form. And also the word transformation is in the investigative question. And also the word transform is in the essential question. So this must have something to do with energy transformations. The essential question, how does energy transform? Or why does something stop on its own? There are two essential questions here. They seem to be related. I wonder if I were to answer one and not the other, if my answer would actually be different. And when I look at it, it says, how does energy transform when an object slides or rolls? Well, an object that's sliding or rolling is obviously going to stop at some point, meaning all of its energy has transformed. So this question, why does something stop on its own, would essentially be the same thing. I'm guessing whatever question I put on my eFolio, I'll probably have the same answer. Probably talk about energy transformations. I'll talk about how energy changes forms. We've been talking about it in class. I'm just not sure where we're going to go with this laboratory. Let me take a look at the investigative questions. Typically, an investigative question gives me some insight into what I'm actually going to experiment with, what my materials are, how I'm going to do it, what kind of question I'm being asked. And as I read this one, it says, I'm going to focus in on these words. Rolling surface affects energy transformation. How does the surface affect an energy transformation? That must mean that I'm going to change the surface that an object rolls on. And the object that I have to roll with is a car. When I look at the procedure starter, it says at a chosen height, determine the gravitational potential energy of a matchbox car. Okay. From what I know, if I put a matchbox car at a certain height, it has a certain amount of energy stored in it because of its height. And that amount of energy, if I kept that height the same, that amount of energy would always be the same. So as I think about it, how would I show energy transformation? Well, if I gave the car the same amount of energy and let it roll, I know from experience when I let an object roll on, like when I let a car roll on the carpet from when I was a little kid, I mean, I knew it just wouldn't roll. And I tried and tried, but I never could get it to roll very far. But if I took it into the kitchen where the floor was nice and flat and hard, it would roll really far. Maybe that's what Mr. Schmidt's going for. Maybe if I change the surface that the car rolls on. But how could I be sure it always had the same amount of starting energy? Well, as I think about it, I'm going to look ahead at the procedure suggestions. And it says he suggests making a ramp. Well, that would do it. Because if I kept the car at the same height and a ramp every time, I would always know I was giving it the same amount of energy. And if it got down to the bottom of the ramp, hopefully, if the ramp is always the same and I've kept that constant, the energy will always be the same. But if I let it roll on carpet, I know that the object's not going to go very far. If I let it roll on the floor of the classroom, it would go much further. If I let it roll on sandpaper, it might go a little further than carpet, but not as far as on the floor. So I can see that the surface is definitely going to affect how the energy leaves the car after it leaves the ramp. Makes sense to me. I think I got a hypothesis. The rougher the surface, the quicker the energy will transform. That makes me think that it won't go as far. So maybe I could restate the hypothesis like this. The rougher the surface, the less far it will go. Oh, that sounds kind of lame. I'll work it out with my group later. Then let's see. The variables would be the roughness of the surface or the type of surface. The independent or the dependent variable. Oh, I always get this mixed up. Let me see if I got them right. Dependent is the thing I measure. Independent is the thing I change. Yeah, I would be changing the surface, and then the independent variable. Oh, I messed up again. Independent variable would be changing the surface, and the dependent variable would be how far it goes on that surface. I could probably do 3 or 4 trials using the same surfaces, and it would make sense. Constants, I'm thinking the height of the car, the type of the ramp. I'm sure we'll come up with others in my group. Procedure, he says suggest making a ramp. I already talked about that. I already thought about that. How can you put these concepts together? GPE. We've been learning about GPE in class. I think it has something to do with work. I'm sure I can calculate it if I found the weight of the car. So I guess I'm going to have to at some point measure the mass of the car, multiply that by the acceleration of gravity, and then multiply that by the height, and I should have the amount of energy stored in the car's height. And let me see. When I look at the data table, there's the car, there's the surface type. I'm guessing that's where I could put like smooth, rough, rougher, ramp height. Well, if this is constant, all these ramp heights should be the same. Initial GPE, if all the ramp heights are the same and I'm using the same car, then the initial GPE should always be the same. The only thing I can think of is I might need to collect information on the distance the car can travel. So I might need to have more data columns and maybe make some observations about maybe the sounds that the car makes, things like that. Analysis. These kinds of things I know I can save for later, so I'm not even going to think about it till later, because usually I need to see the outcome of the experiment before I go any further. At this point, I'm pretty sure I could talk to my group and we could come up with a good investigation. Let's end our Think Aloud.